Day 480 of doing a LeetCode problem every day. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3000, maximum area of longest diagonal rectangle. The difficulty level is easy, but so you already know, we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a 2D zero-index integer array dimensions. For all indices I, 0 is less than or equal to I, and I is less than dimensions.length. Dimensions of I and 0 represent the length, and dimensions of I and 1 represent the width of the rectangle I. Return the area of the rectangle having the longest diagonal. If there are multiple rectangles with the longest diagonal, return the area of the rectangle having the maximum area. All right, y'all, so that sounds pretty simple, but let's take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input dimensions equals a 2D array of integers, first array being 9 and 3, second array being 8 and 6, the output is 48. So let's take a look at this explanation so we can see how they got this output from, how they got this output from this input right here. So it says for index 0, the length is equal to 9 and the width is equal to 3. The diagonal length is equal to the square root of 9 times 9 plus 3 times 3, which equals the square root of 90, which equals 9.487. So let's go through this one step further. So this 9 equals the length and this 3 equals the width. To find the diagonal of this rectangle, so this is corresponds to a rectangle. To find the diagonal length of that rectangle, we need to find the square root of the length times the length plus the width times the width. So that is going to give us 90, so we need to find the square root of 90, and that is equal to 9.487. Then for index 1, it says the length is equal to 8 and the width is equal to 6. So once again, this is the length, this is the width. Then it says to find the diagonal length of that rectangle, we need to find the square root, once again, of the length times the length plus the width times the width, which in this case is 8 times 8 plus 6 times 6, which is going to give us 100. So we need to find the square root of 100, and the square root of 100 is equal to 10. So now this 10 just represents the diagonal length, right? So the diagonal length for this is equal to 10. The diagonal length for this is equal to 9.487. What we want to do is return the area of the rectangle that has the longest diagonal. So we can see, since this diagonal is 10 and this diagonal is 9.487, we want to find the area of this rectangle right here, which would be this rectangle right here. So it says, so the rectangle at index 1 has a greater diagonal length, therefore we return the area, and the area is just the length times the width, which is 8 times 6, which equals 48. So we return 48. That's how we got this 48, because this rectangle has a longer diagonal width, and since it has the longest diagonal length, then we just need to find the area, which is the length times the width, and 8 times 6 is 48. So that's how we got 48. And that's how we knew to choose this rectangle instead of this rectangle, because this rectangle has a larger diagonal diagonal length. So let's take a look at example 2 just to make it make sense in case that didn't. So in example 2, we have our input dimensions equals a 2D array of integers 3 and 4 and 4 and 3. The output is 12. Says the length of the diagonal is the same for both, which is 5. So the maximum area is 5. So as you can see, these are the same numbers. They're just reversed, but in the end, they'll have the same diagonal length. And once we get the area of these rectangles, they'll both be 12. So we could just return 12. So I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So let's get into it. Now, the first thing we're going to do, we're going to come down here outside of the main function. We're going to create another helper function. This is a real quick and simple helper function that's going to return the square of a given integer as a double, and this is going to be used to calculate the width squared and the height squared for the diagonals, right? So for this, we are just going to say func square. So this is just going to handle this. It's going to do the handle the length squared for us and the width squared for us, because as you can see, we have to square the length and we have to square the width in order to get, before we can square root the sum of those. So this is just going to do that for us. We're going to create a helper function for that. We'll call it func. We can call it squared, open up the parentheses, underscore is going to have a val, a value, and that's going to be an integer. So val colon integer. And then we are going to come outside of these parentheses and we are going to return a double, just like that. Boom. Now for the function, all we're just going to do is say double, open up the parentheses, val times val, and that's just going to square our inputs for us. Boom. So now we can come up here to the main function. First thing we need to do is we need to compute the diagonal length for each rectangle, and we're going to use Pythagoras theorem for that, right? So for that, we could just say let diagonal length equal dimensions dot map. Open up the brackets. We're going to get the square root. So we're going to say SQRT. Open up the parentheses. And we're just going to say squared. We're going to call our helper function right here. And we're going to say squared. Open up the parentheses. And we're going to say $0, square bracket 0. So this is going to go through each element in the array, and then it's going to get the first index of that array. So this is going to, this $0 right here is going to represent this array. For example, right, it's going to represent each array. So it represent this array, then it'll represent this array. But for now, it's going to, we'll just stick to this just for understanding purposes. So this $0 is going to represent this whole array. Then the square bracket 0 is going to represent just index 0 of this array that we're looking at. This $0 array, this square bracket 0 is going to look at index 0 of the $0 array, whatever array that might be. Then we still have to add that to the square root of that to the square root of the index 1 in that same array. So for that, we could just say come outside these first parentheses and we could say plus, then we're going to say squared, open up the parentheses again, $0 because we're still the same array, but this time we're going to say square bracket 1 because we want this index, the first index, and not the 0 index. Boom. Then that's it for that part. Then we come right here and we need to find the maximum diagonal length among all of the rectangles, and if no diagonals exist, we could just have an empty input and return 0. So we're going to say guard let max length equal diagonal length. Sorry, y'all. Diagonal lengths dot max. Boom. And once again, that's going to find the array with the maximum diagonal length. Then we could just say else, open up the brackets, and we could just return 0. Boom. Now we need to find all the rectangles whose diagonal length are equal to the maximum. And then we're going to keep only the maximum diagonal rectangle. So we're going to just come underneath this, and we're going to say return diagonal lengths dot enumerated. Open up the put the parentheses. You don't have to put anything in them. Then we're going to come underneath this, and we're going to say dot filter, open up the brackets, we're going to say $0 dot element equals max length. Boom. So that's going to keep only the diagonal or only the max diagonal rectangles. Then we need to extract their indices by coming underneath that, and we're going to say dot map, open up the brackets, $0 dot offset. Boom. Then we need to compute the area of that rectangle, which is the width times the height. So we're going to come underneath that, and we're going to say dot map, open up the brackets, dimensions, square bracket, $0, come outside of the square bracket, and we're going to say square bracket 0. Then we're going to multiply that, so times dimensions again, square bracket 0, or excuse me, square bracket $0, come outside of that, and we're going to say square bracket 1. Boom, and now we need to return the largest area or 0 if none, because it's optional. So we could just come underneath that. We'll say dot max, put the parentheses, then we'll say it's optional, so we'll say question mark, and just put a 0 at the end. That should be all she wrote, y'all. So let's give it a run. Before we submit it, make sure it runs properly. Let's see. Computer's kind of slow today, y'all. I don't know what's going on. Let's see. Okay, cannot find dimensions. It took all that time just to tell me that it's a typo. So let's run it again. Hopefully it works this time. I don't know why my computer's going so slow today. But let's see. Hopefully it's not a time exceeded error and it's just my computer taking all day. Oh my goodness. Another typo. Let's try it again. Let's see. Okay, well at least that was faster. So this should have a G in it. Let's run it again. Let's see, and it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, it's doing something, and it's accepted, y'all. 5 milliseconds beats a -% of users. Don't know what that dash means, but I'll take it, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.